Hello friends, welcome to online batch for engineering mathematics 2. There is an important part in maths, three-dimensional geometry. It contains three topics: cone, cylinder and sphere. So today we are going to study the cone. Friends, you are already familiar with the cone, ice cream cone, or while attending birthday party or arranging birthday party, you have birthday caps. I have a birthday cap. So this is in the shape of cone. This is a vertex for the cone and it has a base. It is in the shape of circle. So cone has a circular base. Got it? First of all, I will introduce cone. I will draw a figure. This is the vertex of cone. Usually, vertex of cone is denoted by A, as cone is a three-dimensional in space. So it is in the form of coordinates x, y, z. But vertex in the form of alpha, beta and gamma. This is the axis of the cone. And this is the slant height. And axis is a height. I will denote height by h. Right? This is an angle which is a semi-vertical angle. We denote it by theta. Obviously, this is the base of the cone which is circular in shape. As this is a circle, so obviously this is the radius denoted by r. Generally, slant height is denoted by L, small l. For this cone, this is a slant height. This is a vertex of the cone and this is a circular base. This is center of circle. A line drawn from vertex and center. This is the height of the cone. And obviously this height is treated as axis of the cone. We already know axis is one type of line. So we may have equation of axis as a line in symmetric form. It is x minus x1 upon a1 equal to y minus y1 upon b1 equal to z minus z1 upon c1. Friends, I will introduce two types of cone. Suppose this is one type of cone. This is a base as a circle and this is center of the circle. This is the axis of the cone. Obviously, this is the center of the circle and this is the vertex of the cone. Alpha, beta and gamma. It has circular base and this is the radius of the circle. So check here, this angle. This angle is not right angle. So two conditions are here. First and second. Here base is circular, but axis is not a perpendicular to the base. This is A type. Another type of cone, B. Again, I will draw a cone. Now let this is a perpendicular. This is radius. Vertex again denote by A. This is base of the cone. Now here also two conditions are there. First, base is not a circular. Remember, in first base is circular. In this second type B, base is not in the shape of circle. Second, here axis is not perpendicular to the base. So it is not in right angle. But here axis is perpendicular to the base. This is said to be an oblique cone. This is cone, but base is not circle here. In both these cases, A as well as B, both conditions at a time are not satisfied. First, here base is circular, but angle is not at right angle. It is not perpendicular to the base. In second condition, here axis is perpendicular to base, but base is not a circle. So in both these cases, A and B, this cone is not a right circular cone. So what does right circular mean? I will draw a third cone. This is center of the circle. This is type C. Here you can see base is circular now. This is axis of the cone. This is a radius A. This is the vertex of the cone. And you can see here axis is perpendicular to the base. So here both the conditions are satisfied. First, base is circular, and second, axis is perpendicular to the base. That means circular base. So in all these three cases, these three types, this is the right circular cone. That means shortly we may summarize that the cone which has base as a circle, that means circular base, and axis is perpendicular to the base. That means if axis perpendicular to the base and base is also circular, then that type of cone is said to be right circular cone. So friends, we have to discuss now about right circular cone. Just we have studied about it. Now this is a cone which has circular base. No doubt this is center of circle and axis is perpendicular to the base circle. This line is the axis. This is the vertex A. Remember, we always denote vertex of the cone by A. Alpha, beta, gamma. This is the radius, so it is R. This is semi-vertical angle. Whole this is a vertical angle of the cone and this is semi-vertical because it's half. It is denoted by theta. This is a slant height. Generally, for this right circular cone, we may say this slant height as a generator of the cone, or it is a generator line. This is circular base. So, this is what about the right circular cone. Vertex of the cone A, semi-vertical angle theta. This is line axis. Radius of the base circle R. So this is the part just we have studied. Introductory part. Check here. This is the height of the cone. Circular base. This is slant height. Vertex of the cone. Vertex is denoted by A. Slant height, it is denoted by L. This is circular based. Radius is R. Height of the cone is H. This is right circular cone. A is a vertex having coordinates in 3 dimensions: alpha, beta, gamma. Semi-vertical angle theta. And this slant height, remember, we denote it as L and it is a generator of the cone. So what is axis of the cone? It is a line which passes through the vertex. This is a vertex and center of the circular base. That means this vertex and center. The line which join both these points. This is the axis of the cone. Generator, it is a line passing through vertex, means A, and any point on the circular base. Suppose this is a point on circle. So vertex and any point on the circle. This line is said to be generator. Now check here. This is the vertex of the cone. This is circular base. Suppose I will take any one of the point. This is suppose the point and this is the vertex of the cone. If I join both these lines, this is the one generator of the cone. Suppose I will take another point on the circle and vertex. If I join both these points again, this will be second generator. If I take this third point, join with vertex, this is third generator. If suppose I take one more point here and join with it vertex, this is another generator. But as we know, there are infinite number of points on the circle. So infinite number of generators are there, right? All the points, if we join with vertex, then infinite number of generators of cone are there. So why we call it as a generator? Because this generator generates whole cone. That means only two lines are there. This is the axis and this is generator. If this axis is fixed, this is vertex A, and if we revolve this line about this axis clockwise or anti-clockwise, so automatically whole figure of cone we will have. Single line can generate total cone, so that line is said to be generator line, and it forms a circle, and this circle is said to be guiding curve. And last, now semi-vertical angle, it is denoted by theta. So this is the angle between axis and generator. This is axis, this is generator, this is semi-curved vertical angle theta. So what is right circular cone? Axis of the cone perpendicular or right angles to the base. This axis should be perpendicular to the base and base should be circle. If these two conditions get satisfied, then obviously it is a right circular cone. Cone is not right circular if both conditions are not satisfied at the same time. That means suppose base is a circle but axis is not perpendicular, and axis is perpendicular but base is not a circle. In both the cases, cone is not right circular. But if both conditions get satisfied, axis is perpendicular, base is a circle, that means it is a right circular cone. This is all about the right circular cone. In the next video, we will discuss about the equation of cone and how will it get obtained. Thank you.